Hey there, grade 9s. Welcome to lesson 2 of chapter 5. Here we're talking about polynomials and like terms and unlike terms. So just kind of as a reminder from last time, we were using these tiles where we have blue representing x squared, a blue long kind of rod represents x, a little square represents 1, and then if it's in red, it was all negative. Okay, I'm going to erase this board because I'm going to be using both of them, and we're going to start with using the pictures, and then we're going to try to get away from it a little bit just to look at the terms themselves. All right, so let's say we have something that looks like this, and then I'm going to group them naturally first. Sometimes they might not be grouped. Okay, so if we've got something that looks like this, and then, oops. Yeah. Okay, so if I was to actually go and write it out, I would have something that might look like this. So I might have 2x squared minus x squared minus 4x plus 2 minus 3. Okay, so this is what we're actually going to try to get into. A little bit more of this is where we're actually trying to eliminate certain things. So what I can do is I can join these. Okay, similar to when we're talking about like integers. Okay, when we have a positive and a negative, they kind of cancel each other out. So if we have a positive x squared and a negative x squared, they're just kind of eliminating each other. So if we have, for example, 2x squared minus x squared, we have 2 here and 1 here. We're eventually going to get 1x squared. We're just going to be down to one of them. Okay, we don't have anything that the x's will eliminate, so we're still going to have our 4x. And then here we have, once again, we have these kind of 0 pairs that we can kind of group together. So that's going to leave us with -1. Okay, so if I eliminate everything, okay, this is what the whole thing should actually look like. Okay, something like this. Okay, so we're going to try to get more into, so once again, I have 1x squared minus 4x minus 1. Okay, which is what we are doing when we kind of eliminate stuff. So we're going to work a little bit more into using the numbers themselves. Okay, and my black is kind of wearing out, so I might switch to green as we move forward. So let's go through a couple examples. Okay, and I'm going to have you guys group everything first. Okay, so you're going to group the like terms and the unlike terms. So once again, you can't add together x's and x squareds. Okay, if it's an x squared, it has to add with an x squared. If it's a x, it has to add with an x. If it's just a number, they can add or subtract with the numbers. So if we have something like this, so 4n squared, and it doesn't matter what the variable is. Okay, well it does, sorry. If you have different variables, then they can't be put together. Minus 3n minus 3 plus 5n minus 2n squared. Okay, so give this one a go. Try to match everything together, and group your like terms. Okay, so I'm going to start with my n squareds. So I have positive 4n squared and I have negative 2n squared. So when I add them together, I'm going to be left with positive 2n squared. So this is gone, and I can actually just go and eliminate things as I'm going through. Okay. Next I have my n's. So I have negative 3n and positive 5n. So that's going to give me plus 2n. So my n's are gone. Here I have -1 and -3, which is going to give me -4. Okay, so this is how we would group them. Okay, and that way, then I'm done. Okay, I basically simplified that equation. All right, so let's do another one. Once again, feel free to pause it. So if I've got 14x squared minus 11 plus 30x plus 3 plus 15x, and I have to go down, minus 25x squared. Okay, sorry, I had to do it in 2 lines. I started too big and not far enough. All right. So once again, group your like terms, and then give me your final equation. Okay. So what I'm going to do is I'm going to take my x squareds first. I've got negative 25 and I have 14. So when I subtract them, I'm going to have negative 11x squared. Okay, these are gone. I'm going to look at my x's. I have positive 30 and positive 15, which is going to give me positive 45x. Those are gone. Here I've got negative 3 and negative 11 and positive 3, which is going to give me negative 8. All right. Okay, let's move on because they're going to get a little bit harder. Okay. This next one, we're going to start with a model. So this is kind of a question, a problem question that you might have. All right. So let's say we have something that looks like this. Oh, what's going on with my marker? We've got a rectangle that's represented by x, 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 and x. Okay, because that's technically the length of an x squared. Okay, the length of an x squared is going to be x. So it might ask, what is the perimeter? Okay, what is the perimeter? Okay, well, I can technically say my length is 3x plus x. So that's one side. This side, the bottom side, is going to be plus 3x again, and then plus x. Okay, this is how I would actually calculate my perimeter. Okay, because the length of one side is x, so the whole area is x squared. Okay, so I don't want you to if we're talking about the area of this whole thing, it's a little different than talking about the volume or the perimeter. Okay, the perimeter, we're just looking at the length. So we know that this length is an x, not an x squared. Okay, so when I see all this, I can add my terms together. So I have 4x's plus another 3x's and another x. So 3 and 1 is 4, and 3 is 7, and 1 is 8. So I could combine this and say that the perimeter is 8x. Okay. So I want to give another example just to kind of talk about the perimeter situation, so that we aren't confusing it too much. What if I have something like this? Okay. Let's go 3. So it looks like this. So when I'm breaking this down, these are x tiles. So the length here is x, 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 and these are going to be 1 and 1. Okay, keep in mind, like I talked about before, this square represents 1. So the width of that would represent 1. Okay, so how would I find the perimeter in something like this? Well, I have to add everything together. So I've got 3x, which is the length of the top. I have 2, and then I have 3x again, and 2. Okay, I have to add all 4 sides to find the perimeter. Okay, so to break it down, I'm going to take my like terms. So I'm going to have 3x and 3x is going to be 6x, and I have 2 and 2 is going to be 4. So 6x plus 4 is going to be the distance all around my perimeter. Okay. All right. Now let's do one without a picture. Okay. So let's say we have a perimeter of a rectangle that is represented by 4a plus 2. Okay. 4a plus 2. Okay, this is the whole perimeter. So what I'm actually trying to find is what is the side length, or what are the side lengths. Okay, so I can actually break this down into kind of smaller terms. Okay, so because like I was saying last time, I'm going to have it when I'm talking about a perimeter. I'm going to have this as one and this as another. Okay, so if I've got 4a plus 1 or 4a plus 2. This is going to be half the length, and this is going to be the other half of the length, okay, all the way around the perimeter. So let's break it down into different terms. So I can say I have 2a plus 1 plus 2a plus 1. Okay, so what did I essentially do? I took these and I went all the way around twice. Okay, so now I can't necessarily have a 2a plus 1, so what I actually need to do is I need to break it out even more. Okay, so inside of each of these I'm going to have a plus 1. Okay, so what did I do? I took an a out of this one. Okay, plus a plus 1. So this is actually going to tell me what my full side is. Okay, so what does it look like? Well, it would look something like this. I would have an a. Okay, so if this is a, and 1. Okay, this would be my length, and then a plus 1. So I have a, which is the length of 1, okay, and then a plus 1, which is my length of the other side. So this is what my rectangle might look like, or my rectangle might look like, which is actually going to help me out quite a bit. Okay. Let's do another example similar to this one. What if it's giving me the perimeter to equal 10b? Okay, what if this is the perimeter to equal 10b? Okay, so the way that I would figure it out is the perimeter. So the perimeter, like I said, is the sum of the equal parts of all the dimensions. Okay, so there's actually quite a few possible answers for this one. But one that we could do is if we're breaking it down. Basically, what we would be able to have is we'd have 10b plus 10b, or sorry, 5b plus 5b. Okay, but that won't actually create a rectangle. Okay, that'll just kind of create a line. So we're just having the top and the bottom. So let's break this up even more. We could have it as 4b plus 1b plus 4b plus 1b. Okay, so this would give us our length and our width and our length and our width. So the way that it would look is if we had kind of a rectangle. Okay, this would be b, 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 and b. So we have 4b by 1b. Okay, another possible answer would be 3b plus 2b plus 3b plus 2b. Okay, so that one would look probably something more along the lines of this. Okay, so we'd have 3b and 2b. Okay, this might be quite complicated right now, but we'll get into it a little bit more in the Zoom, and I can explain and answer any questions that anyone has. Okay, last one that we're going to go through. This one might be a little bit more confusing, but we're still just grouping our like terms. Okay, so if we have something like 4xy, okay, now we've got multiple terms. Minus y squared, okay, minus 3x squared, plus 2xy, I'm going to have to go to another line, minus x, minus 3y squared. So once again, I'm joining my common terms. So I can't necessarily join an x to an xy. I can join xy's with xy's. So let's start with that. I have 4xy and I have 2xy. So that's going to give me 6 xy's. Okay. Then let's look at my y squareds. I have, so this is gone and this is gone. Okay, I have negative 3y squares and I have a y squared here. So that's going to give me negative 4y squareds. So these are gone. Okay, let's look at my x squared. Well, I only have the one term, so minus 3x squared, okay, minus x. And that's it. So all I'm doing is I'm grouping my like terms, and I have to make sure that those like terms are grouped together. All right, so that's going to be it for today's lesson. Sorry, it was a lot longer than usual. There's a lot of examples to go through, and I'm sure that there's going to be a ton of questions. So please make sure that you bring those to the Zoom chat, and then give your homework a try. All right, good luck.